In this video clip, we learn about some of the common discrete time signal. Last time we have learned about how to obtain a discrete time signal from sampling method. Here are some of the discrete time signal that you will usually see in this class. The first one that I like to introduce is called delta n. Delta n is called a unit response function, unit impulse functions. The unit impulse function is a very simple define. It's defined as delta n equal to 0 if n not equal to 0, and delta n equal to 1 if n equal to 0. So when you make a plot, delta n would have a plot something like this. Okay, so it's equal to 1 when n equal to 0, and it's equal to 0 when n equal to something else. Okay, so it would go something like that. Okay, and here also minus 2. Okay, so around here. Okay, so that would be delta n. The plot that we are plotting is called a stem plot. We normally use a stem plot in order to display the discrete time signal. The second signal that I'd like you to know, okay, is called a unit step function, delta n. Okay. Notice that the unit impulse only has one value, and it exists only n equal to 0. But un is a infinitely long signal because it's equal to 0, is equal to 1 when n greater than or equal to 0, and is equal to 0 when n less than 0. Notice that every discrete time signal only defined when n is integer. Okay, so if n is non-integer, then the signal is undefined. So here un equal to 1 when n equal to 0, 1, 2, 3, 4, and so on. Okay, so we use a stem plot like so. So this type of stem plot you see it's very often. And here 2, 3, 4, and then equal to 0, 0, 0 when n is negative. Okay, minus 1, minus 2, minus 3. So this is delta n. Notice that when you write un, you can write it like this. Okay, un equal to perhaps dot, 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 and then 0, and then 1, 1, 1, and so on. Okay, so 1 start at n equal to 0, so we mark the arrow to show that it is a 0 position. Okay, so delta n the same thing, so you can write it as 0, 1, 0, and then dot, dot, dot. Okay, so that is the another way of writing the function. There are many other things that you could do, okay, in order to obtain a different kind of signal. Okay, for example, you could even try to write a signal like perhaps xn is a sinusoid. Okay, so here we have a cosine and then omega naught n. Okay, so this is a signal that is sinusoid. Okay, so depending on omega naught and the value of n, okay, so you get different sample. Okay, so if it's cosine, perhaps it might look something like this. Okay, so depending on how often or how frequent you do the sampling, so you get different kind of sample. Okay, like so. Okay, so that is the signal that is sinusoidal. Okay, so you could also have the signal like this one. Okay, in the next section, we learn how to sampling the sinusoidal signal and see what happens if we sample a sinusoidal signal. Okay, goodbye.